Well, hi dear friends, welcome back to the new chapter, that is the second chapter of second PUC mathematics, that is inverse trigonometric functions, which is very important chapter with respect to differentiation as well as integration. If you have not watched the previous videos, please go and watch the previous videos of relations and functions, because we are going to use some of the concepts from the relations and functions to understand inverse trigonometric functions. Okay, so before that, let me tell you one concept, that is inverse of a function, which is from relations and functions, which I haven't spoke of actually. Well, ಇವಾಗ ಏನು ಮಾಡೋಣ ಅಂದರೆ, ಲೆಟ್ಸ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ವಾಟ್ ಈಸ್ ಇನ್ವರ್ಸ್ ಆಫ್ ಅ ಫಂಕ್ಷನ್. ಲೆಟ್ಸ್ ಫಾರ್ಗೆಟ್ ಅಬೌಟ್ ಟ್ರಿಗೊನೋಮೆಟ್ರಿಕ್ ಫಂಕ್ಷನ್ಸ್. ಫಾರ್ ಟೈಮ್ ಬೀಯಿಂಗ್, ಲೆಟ್ಸ್ ಫಾರ್ಗೆಟ್ ಅಬೌಟ್ ಇನ್ವರ್ಸ್ ಟ್ರಿಗೊನೋಮೆಟ್ರಿಕ್ ಫಂಕ್ಷನ್ಸ್. ಓನ್ಲಿ ವಿಲ್ ಸಿ ವಾಟ್ ಈಸ್ ಇನ್ವರ್ಸ್ ಆಫ್ ಅ ಫಂಕ್ಷನ್ಸ್ ಮೀನ್. Okay, yeah. Let's see. I have written two examples here. Example 1 and example 2. You need to tell me whether the first function f1 is 1 1 and onto. You can easily see that each element of A is connected to only one element, isn't it? 1 is connected to A, 2 is connected to B, 3 is connected to C. All are connected differently. So I can say this is 1 1. Yes or no? So let me write here itself. It is 1 1. How about onto? It is not onto because D is left, not connected. So this is not onto. Okay? Yeah. Now let's consider this function. You can easily see that 1 and 2 are connected to same element. So this is not 1 1. This is not 1 1. 3 is connected to B. Okay. All are connected in codomain. Nothing is left free. So this is onto. Well, I hope you're understanding. Well, inverse of a function means generally this is written as f1 from A to B, and this is f2 from A to B. Okay, inverse of f1 means we write f1 inverse power ಅಲ್ಲಿ -1 ಬರಬೇಕು, and we change domain and codomain. Domain and codomain reverse ಮಾಡಬೇಕು. So if I try to find the inverse of this function f1, so what I'll get is, like, I have to reverse the things. Okay, so this is my B and this is my A, and this will be f1 inverse. Here I'll be having A, B, C, D, and here I'll be having 1 2 3. See the connection, A is connected to 1 and B is connected to 2 and C is connected to 3. Yeah, this is our inverse of a function. We write like this, but there is a problem now. What the problem is, when I spoke of functions, ನಿಮ್ಗೆ ನೆನಪಿರ್ಬೋದು, ನಾನು ರಿಲೇಷನ್ಸ್ ಆ್ಯಂಡ್ ಫಂಕ್ಷನ್ಸಲ್ಲಿ ಫಂಕ್ಷನ್ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದಾಗ ಬೇಸಿಕ್ಸ್ ಹೇಳಬೇಕಾದ್ರೆ ಐ ಟೋಲ್ಡ್ ಯು ಒನ್ ಥಿಂಗ್. ಒಂದು ಯಾವುದಾದ್ರೂ ರಿಲೇಷನ್ ಫಂಕ್ಷನ್ ಆಗಬೇಕು ಅಂದರೆ ಇನ್ ದ ಡೊಮೇನ್ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಗೂ ಕನೆಕ್ಷನ್ ಇರಬೇಕು ಅಂತ ಹೇಳಿದ್ದೆ. ಯಾವುದು ಕೂಡ ಖಾಲಿ ಉಳಿಬಾರ್ದು ಅಂತ ಹೇಳಿದ್ದೆ ಅಲ್ವಾ? ಸೊ ಬಟ್ ಇನ್ ದಿಸ್ ಕೇಸ್ ಡಿ ಈಸ್ ಲೆಫ್ಟ್ ನಾಟ್ ಕನೆಕ್ಟೆಡ್. D has no image in set A. So I can say that this is not a function. Idu function alla. So what I'm trying to say is, if the function is 1 1 but not onto, inverse of this function, inverse does not exist. Inverse does not exist. I wanted to tell this one for you, because D is left not connected, isn't it? Yeah. Now in this case, in the second case, let's see whether inverse for this function exists or not. So what I'll do is, I'll take B on this side, A on this side. This is my f2 inverse. Okay, here I'll be having A and B and 1 2 3, 1 2 3. So A is connected to 1 as well as to 3. Now you see whether this is a proper function. No, it is not a proper function, because we already know that function ಯಾವಾಗುತ್ತೆ ಹೇಳಿ, ಒಂದು ಎಲಿಮೆಂಟ್ಗೆ ಒಂದೇ ಕನೆಕ್ಷನ್ ಇರಬೇಕು, ಅವಾಗ ಮಾತ್ರ ಅದು ಫಂಕ್ಷನ್ ಆಗೋದಲ್ವಾ. ಅಂದರೆ ಇನ್ವರ್ಸ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗೋದೇ ಇಲ್ಲ. ಇಲ್ಲೂ ಕೂಡ ಇನ್ವರ್ಸ್ ಡಸ್ ನಾಟ್ ಎಕ್ಸಿಸ್ಟ್. ಇನ್ವರ್ಸ್ ಡಸ್ ನಾಟ್ ಎಕ್ಸಿಸ್ಟ್ ಅಂದರೆ ಫಸ್ಟ್ ಕೇಸಲ್ಲಿ ಏನಾಗಿತ್ತು ಹೇಳಿ, ಕೊಟ್ಟಿರೋ ಫಂಕ್ಷನ್ 1 ಇತ್ತು, ಆನ್ 2 ಇರಲಿಲ್ಲ. ಅವಾಗ ನಾನು ಇನ್ವರ್ಸ್ ಬರೀಲಿಕ್ಕೆ ಹೋದೆ, ಇನ್ವರ್ಸ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗಲಿಲ್ಲ. ಸೆಕೆಂಡ್ ಕೇಸಲ್ಲಿ ಕೂಡ ಹಾಗೆ ಇತ್ತು. F2 ಫಂಕ್ಷನ್ ಯಾವ ಥರ ಇದೆ, 1 ಇಲ್ಲ ಬಟ್ ಆನ್ 2 ಇದೆ, ಅವಾಗಲೂ ಕೂಡ ಇನ್ವರ್ಸ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗಿಲ್ಲ. ಸೊ ನನ್ನ ಹತ್ರ ಲಾಸ್ಟ್ ಒಂದು ಕೇಸ್ ಉಳಿದಿದೆ, ಏನು ತೊಗೊಳ್ಳೋಂಥ ಫಂಕ್ಷನನ್ನು 1 ಮತ್ತು ಆನ್ 2 ಎರಡೂ ಇರೋದನ್ನು ತೊಗೊಳ್ಬೇಕು, ಅದಕ್ಕೆ ಇನ್ವರ್ಸ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತಾ ಇಲ್ಲ ಚೆಕ್ ಮಾಡಬೇಕು. ಅದನ್ನು ನಾನು ಚೆಕ್ ಮಾಡಿ ತೋರಿಸ್ತೀನಿ. ಸೊ ಪ್ಲೀಸ್ ಪಾಸ್ ದ ವಿಡಿಯೋ ಟು ನೋಟ್ ಇಟ್ ಡೌನ್. Yeah, now let's take the third example. This is F3 function, okay? Here you can see that it is 1, 1 because all are connected to different elements, and this is on 2 because nothing is left free. So I can say this is 1, 1 and on 2. Now let me try to write inverse for this. Inverse means ulta. Just remember, inverse means ulta. So what it will look like is, I'll write B in this side, A in this side. This is B and this is A. Here I'll be having A, B, C, 1, 2, 3. So A is connected to 1, B is connected to 2, C is connected to 3. Now check whether it's a proper function or not. Yes, it is a function. Yes or no? Yes. So then we can say inverse exist. Inverse exist. So we got a very, very important conclusion. I'll write here as a note. What I'll write is, for any function f of x, for any function f of x, inverse exist if and only if f of x is both 1, 1 and on 2. Both 1, 1 and on 2. So this is the golden statement I just got now from the conclusion. Whatever we spent 5 to 6 minutes, that is the conclusion is this one. ಅಂದರೆ ಯಾವುದಾದ್ರೂ ಒಂದು ಫಂಕ್ಷನ್ಗೆ ಇನ್ವರ್ಸ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗಬೇಕು. ಫಸ್ಟ್ ಆಫ್ ಆಲ್ ಇನ್ವರ್ಸ್ ಅಂದರೆ ಏನು ಹೇಳಿ, ಡೊಮೇನ್ ಮತ್ತು ಕೋಡೊಮೇನ್ನ ರಿವರ್ಸ್ ಮಾಡೋದು ಅಷ್ಟೇ, ಚೇಂಜ್ ಮಾಡೋದು, ಉಲ್ಟಾ ಮಾಡೋದು ಅಂತ ಅರ್ಥ. ಸೊ ಇನ್ವರ್ಸ್ ಯಾವಾಗ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತಂದರೆ, ನಾವು ಉಲ್ಟಾ ಯಾವಾಗ ಬರೀಬಹುದು ಅಂದರೆ, ಕೊಟ್ಟಿರೋ ಫಂಕ್ಷನ್ ಏನಿರಬೇಕು ಹೇಳಿ, 1, 1 ಇರಬೇಕು, ಆನ್ 2 ಇರಬೇಕು, ಅವಾಗ ಮಾತ್ರ ಇನ್ವರ್ಸ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತೆ, ಇಲ್ಲ ಅಂದರೆ ಇಲ್ಲ. ದಿಸ್ ಇಸ್ ಒನ್ ಕನ್ಸೆಪ್ಟ್ ವಿಚ್ ಇಸ್ ಯು ಹ್ಯಾವ್ ಟು ನೋ ಇಟ್. ಓಕೆ, ಸೊ ಇಫ್ ಯು ನೋ ದಿಸ್ ಕನ್ಸೆಪ್ಟ್, ದೆನ್ ವಿ ಕ್ಯಾನ್ ಮೂವ್ ಆನ್ ಟು trigonometric, inverse trigonometric functions. You can pause the video and note it down, please. Well, dear friends, now let's understand inverse trigonometric functions. Now you can see on the board what I have written is sine function. Which function? Sine function. In this side I have all the angles, in this side I have values. Okay, so this will be till 1, this will be minus 1. Okay, yeah, you know that sine 0 degree will be always 0. Yes or no? You know the table from first year? Yes or no? Yeah. So sine 0 is always 0. What is sine of 30 degree? 1/2. Sine of 60 is √3/2. Sine of minus 30 degrees, very good, minus 1/2. Sine of minus 60 will be minus √3/2. Now I need to find what is sine 120. Sine of 120 degree. Sine of 120 degree. So this is equal to, how do we write this one? We write this one sine of 90 plus 30. So this is cos 30, isn't it? Which is equal to √3/2. Matlab cos 120 is √3/2. And what is sine of 150 degree? That is equal to sine of 90 plus 60 degree, which is equal to cos of 60 degree, which is equal to 1/2. So 150 degree is 1/2. So similarly, yeah, we can write for negative also, negative of 120 and negative of 150 we can write. Now the question here is, let me take those two values also, that is minus 120 and minus 150. Minus 120 will be connected to, you can say minus 120 will be connected to minus √3/2. Okay, and minus 120 120, where is 120 connected? Sorry, 120 is connected to root 3 by 2. Yeah, 120 is connected to root 3 by 2 and this is connected to minus half. Yeah. Well, now we can easily see that this function, sine function, for these values, is it 1, 1 or not? This is my question. Yeah, you can see here one important point. This is not 1, 1 function because sine of, where is that? Sine of 60 degree is connected to root 3 by 2 and sine of 120 degree is also connected to root 3 by 2. These two both values are connected to root 3 by 2. Similarly, sine 30 and sine 150 are connected to 1 by 2 and similar to the above case. So obviously this is not a 1, 1 function. If sine is not a 1, 1 function, then how can we write inverse for that? Because sine inverse exists only if sine is 1, 1 and onto. Just now we got a conclusion. ಅಂದರೆ ಏನಂತ ಹೇಳ್ತಿದ್ದೀನಿ ನಾನು, ಸೈನ್ ಇನ್ವರ್ಸ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತೆ ಯಾವಾಗ ಅಂದರೆ ಕೊಟ್ಟಿರೋ ಸೈನ್ ಫಂಕ್ಷನ್ನು ಅದು 1, 1 ಇರಬೇಕು, ಆನ್ಟುನೂ ಇರಬೇಕು. ಈಗ ಪ್ರಾಬ್ಲಮ್ ಏನಾಗ್ತಿದೆ ಅಂದರೆ ದಿಸ್ ಈಸ್ ನಾಟ್ 1, 1, ಅದು 1, 1 ಇಲ್ಲೇ ಇಲ್ಲ. ಸೊ 1, 1 ಇಲ್ಲ ಅಂದರೆ ಇನ್ವರ್ಸ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗೋದೇ ಇಲ್ಲ. ಈಸಂಟ್ ಇಟ್? Yeah, you are right. So then how come we have this chapter inverse trigonometric function? You may ask me this doubt. Yes, they have taken this chapter inverse trigonometric function because, as you know, these the values more than 90 will give me the same values as between 0 to 90. So they will not take these two values, like that is 120 degree and 150 degree. They will restrict the domain. ಹೇಗೆ ರಿಸ್ಟ್ರಿಕ್ಟ್ ಮಾಡ್ತಾರಂದರೆ, ಐ ಹೋಪ್ ಯು ಆರ್ ಟೇಕನ್ ದಿಸ್ ಒನ್. ದೇ ವಿಲ್ ರಿಸ್ಟ್ರಿಕ್ಟ್ ದ ಡೊಮೇನ್ ಲೈಕ್ ದಿಸ್. They will take new sets like this for sine function. Here minus 1 to plus 1. Here they will take only minus 90 degree to plus 90 degree. Only between these two values. You can have 0, 30 degree, 60, 45 degree, 60 degree and 90. Here minus 30, minus 45 and minus 60. Still we have these are standard angles which I am taking. Still you will be having like 15 degree, 16 degree, 17 degree. Avella irtave, but we don't write them because we know the standard values for sine. So that is why I am just writing these things. Okay. So as you can see, these are the values and let me write sine 0 will be connected to 0, 30 will be connected to 1 by 2, 45 will be connected to 1 by root 2, 60 will be connected to root 3 by 2. Isn't it? Yeah. Now minus 30 will be connected to minus half, minus 45 will be connected to minus 1 by root 2 and this is minus root 3 by 2 and this is minus 1 by 2. Now you can see that whatever the function that I have written now, that is sine function, from here let's say this is an angle and this is a value, it is both 1, 1 and onto. Isn't it? Still there are values here in between that can be connected with the angles. That's not a problem. So this is both 1, 1 as well as onto. So for this function we can write the inverse. ಸೊ ನಾವು ಪ್ರತಿಯೊಂದು ಟ್ರಿಗ್ನೋಮೆಟ್ರಿಕ್ ಫಂಕ್ಷನ್ಸ್ಗೆ ಇನ್ವರ್ಸ್ ಬರೀಬಹುದು. ಯಾವಾಗ ಅಂದರೆ ಕೊಟ್ಟಿರೋ ಡೊಮೇನನ್ನು ರಿಸ್ಟ್ರಿಕ್ಟ್ ಮಾಡಬೇಕು. ಏನು ಮಾಡಬೇಕು? ವಿ ಹ್ಯಾವ್ ಟು ರಿಸ್ಟ್ರಿಕ್ಟ್ ದ ಡೊಮೇನ್. ಫಾರ್ ಸೈನ್ ಫಂಕ್ಷನ್ ಐ ಜಸ್ಟ್ ಎಕ್ಸ್ಪ್ಲೇನ್ಡ್ ಯು ಫಾರ್ ಸೈನ್ ಫಂಕ್ಷನ್. ದ ಸಿಮಿಲರ್ ವೇ ವಿ ಕ್ಯಾನ್ ಡೂ ಫಾರ್ ಆಲ್ ಅದರ್ 5 ಟ್ರಿಗ್ನೋಮೆಟ್ರಿಕ್ ಫಂಕ್ಷನ್ಸ್. ಓಕೆನಾ? ಸೊ for sine function, if we restrict the domain from 90 degree to minus 90 degree, then only the function will become both 1, 1 and onto, and hence we can write inverse for that. Similarly, in the same way we have done the restriction for remaining 5 trigonometric functions. Okay? Yeah. I hope you understood this concept. Now let me tell you one more thing. You know, whenever I write sine of something and I'll get answer. Okay? So whenever I write sine, inside will be always an angle, and here it will be value. Whenever I write sine, in the sine function we will be having angle and the answer will be value. But in this chapter, what we are going to do is we are going to do ulta things. Matlab, we will write sine inverse. When I write sine inverse, here I will be writing value and here I will be getting angle as an answer. For example, I can tell you like this: sine of 30 degree, you know what it is? Half. This is trigonometry what you have studied in first year. In this year, what we are going to do now is sine inverse of half, which is equal to 30 degree. So see, you can easily see that in the sine function we will be having angle as a domain, and in sine inverse we will be having value as the domain. This is very, very important. Well, as I said, there is a restriction of domain for all the trigonometric functions. So now I am going to give you one table which is very important, wherein we are going to tell what are the domain for sine inverse and what will be its range. Domain and range I am going to tell you because that's very important. That will come for 1 mark. So please pause the video to note it down. Well, dear students, this is the table that you have to remember. What it tells is, this gives me the idea of domain and range for all inverse trigonometric function. For example, if I have sine inverse x, whatever we can write, only we have to write only values here, isn't it? So the domain will be from -1 to +1. Other than these two, other than the values between -1 and +1, we cannot write any other, or like we cannot write sine inverse of 2. That does not exist. I hope all of you studied this in first year. Okay, so this is the domain and the range will be from -π/2 to +π/2, and this is also called as principal value branch. And this question will be asked in the exam. For example, they'll ask like this: write the principal value branch for cos inverse x. Question in ready, write the principal value branch of cos inverse x, and you have to write the answer as 0 to pi. I think in 2020 they asked a question for sec inverse x. What is the principal value branch of sec inverse x? So the answer is 0 to pi in the open close bracket minus π/2. So you have to remember this particular table so that you can answer 1 mark question. Please take it down or take the screenshot. Well, dear students, next concept is properties of inverse trigonometric functions. We will be having like almost 6 to 7 types of properties. The first type of property is sine inverse of 1/x is equal to cosec inverse x with given these conditions. Let's not worry about these conditions because they'll be like that restriction of domain and codomain. Okay, yeah. So cos inverse of 1/x is equal to sec inverse of x, and tan inverse of 1/x equal to cot inverse of x. So these are the properties. Well, I'll tell you how to prove this property. I'll tell you for only the first one. So let's prove the first one. Okay, so what I'll do is I'll take the first one, that is sine inverse 1/x is equal to cosec inverse x. Okay, so what I'll do, I'll start with RHS. Let I will write here. Okay, I'll write here cosec inverse x is equal to, let's take it as y. Okay, I have taken cosec inverse x equal to y, and I can write x equal to cosec y. How? This cosec inverse goes on that side. I hope all of you know that. If cosec inverse goes on that side, becomes cosec. Okay, so now I'll write this as x equal to cosec. I can write it as 1/sine y, isn't it? Because cosec and sec are reciprocal to each other, and I can write this as sine y is equal to 1/x, because sine y goes this side, x comes this side. Now we can say y is equal to sine inverse 1/x. How? I have taken sine to that side, that becomes sine inverse. I hope you're understanding, isn't it? Yeah. Now what is y? Y I have taken as cosec inverse x. So cosec inverse x is equal to sine inverse 1 by x, and that's what our result is. Well, I hope you got how I proved it. Here in this proof, what actually you should know is, you should know this transition, that is cosec and sine are reciprocal to each other. That is concept, that is one concept which I used and I derived it. Well, that is how I did it for first one. Second and 3 you can do it by yourself by using the same reciprocal relation concept. So this is the property 1. Well, let's understand the second type of properties, that is sine inverse of minus x is equal to minus of sine inverse x when x belongs to minus 1 to plus 1. Similarly for other two, sine, tan inverse and cosec inverse. What actually happening is just minus sign which is there inside sine inverse is coming outside. That is the only thing you have to remember. Okay, so let me give the proof for the first one. The rest two you can do it by yourself. Okay, yeah, I'll start with LHS. I'll write let sine inverse of minus x equal to y. Okay, now let me take sine inverse on the other side. So this will be minus x equal to sine y. What I have done, I have taken sine inverse on that side. Well, now let me take minus on the other side. So this is x equal to minus of sine y. And I hope all of you know one basics from first year or 10th standard, that is sine of minus theta is always equal to sine theta. This is the basics that you have seen in 10th standard or in first year. Whenever we have negative angle inside the sine function, that negative should come outside. Okay, now I'm using the same concept here. See, this is x equal to minus is outside the sine, I'll take it inside. This will be sine of minus y by using this basics, isn't it? Now I'll take this sine on this side. Okay, so sine comes this side, this will be sine inverse of x is equal to minus y, or let me take minus sign again back to this side. This is minus of sine inverse x is equal to y. Now what is y? We have taken y as sine inverse of minus x. So this is minus sine inverse x is equal to y, means sine inverse of minus x, and hence that's our proof. I hope these are simple proofs which will not come for exam, by the way. Only for your understanding I am telling these proofs. There are some proofs they will come for exam, but these are only for your understanding I am telling these proofs. Well, so remember, only for sine, tan and cosec, if we have negative value, that negative will come outside. That's what actually we wanted from this property. Well, please pause the video and take it down. Well, let's understand property number 3, which says to me that cos inverse of minus x is equal to pi minus cos inverse x. So observe it carefully, my dear friends. ಏನಾಗ್ತಿದೆ ಅಂದರೆ ಆವಾಗಲೇ in the 3, that is sine, tan and cosec, ಅಲ್ಲಿ ನೆಗೆಟಿವ್ ಸೈನ್ ಇದ್ದಾಗ that negative just comes outside. Nothing will happen. ಅಷ್ಟೇ ಆಗೋದಲ್ಲಿ. But in these 3 cases, we will not get only minus. Along with that, we will be having pi also. So in the exam, they are going to ask such type of questions. Okay. So I'll tell you the proof for one, and the rest two you can do it by yourself. Okay. So let's start with this proof. Again, I'll start with the assumption that let cos inverse of minus x is equal to y. Let's take it as y. So what I'll do now, I'll take cos inverse on the other side. So I'll be getting minus x equal to cos y. Isn't it? Cos inverse goes that side, becomes cos y. Now, ಈಗ minus sign na akada ತಗೊಳ್ಳೋಣ. So what will happen? X equal to minus of cos y. These steps are similar to what we just did for sine inverse. ಅಲ್ವಾ? But ಇವಾಗ I cannot take this minus sign directly inside because we know the basics from first year or 10th standard. Cos of minus theta will be always cos theta. Negative sign does not make any problem for cos theta. So I cannot write this minus directly inside as I just did for sine. Ad madlik nange barudilla. I hope you're understanding. So I have to make some adjustment here. Somehow I have to remove this minus sign. How do we do that? Very good. You should be knowing one concept, that is cos of pi minus theta is equal to minus of cos theta. This is again from first year. Idu first year ಹೇಳ್ತಾರೆ ನಿಮಗೆ. Cos of pi minus theta ಅಂದರೆ minus cos theta. ಏನಕ್ಕೆ ಹೇಳಿ? ಮೈನಸ್ ಏನಕ್ಕೆ ಬರುತ್ತೆ? pi ಅಂದರೆ 180 ಡಿಗ್ರಿ. 180 minus something ಅಂದರೆ ಸೆಕೆಂಡ್ ಕ್ವಾಡ್ರಂಟ್. ಸೆಕೆಂಡ್ ಕ್ವಾಡ್ರಂಟಲ್ಲಿ ಕಾಸ್ ನೆಗೆಟಿವ್ ಇರಬೇಕಲ್ವಾ? So that's why we get this one. So what I'll do is, anyway I have minus sign, isn't it? This minus sign can be removed if I replace theta with pi minus theta. So what I'll do is, I will write x, I will not write minus sign, instead I'll write cos of pi minus y. Arthaita, how I am removing minus sign? That is very important. Now cos comes this side, this will be cos inverse of x is equal to pi minus y. Now cos inverse of x is equal to pi minus, what is y? Y we have assumed that as cos inverse of minus x. I think we got the proof. No, we haven't got the proof yet. We'll take this side, this term left hand side, this one right hand side. So what I'll get cos inverse of minus x is equal to pi minus cos inverse x, and that's our proof. This is very important. I hope you are ಇದನ್ನು ನಿಮಗೆ ಪ್ರೂವ್ ಮಾಡ್ಲಿಕ್ಕೆ ಬರುತ್ತೆ ಓನ್ಲಿ ವೆನ್ ಯು ನೋ ದೀಸ್ ಟು ಬೇಸಿಕ್ಸ್. ಅವೆರಡು ಬೇಸಿಕ್ಸ್ ಗೊತ್ತಿದ್ರೆ ಮಾತ್ರ ನಿಮಗೆ ಇದು ಮಾಡ್ಲಿಕ್ಕೆ ಬರುತ್ತೆ. ವೆಲ್, ಪ್ಲೀಸ್ ಪಾಸ್ ದ ವಿಡಿಯೋ ಟು ನೋಟ್ ಇಟ್ ಡೌನ್. ವೆಲ್ ಡಿಯರ್ ಸ್ಟೂಡೆಂಟ್ಸ್, ಇಷ್ಟೊತ್ತು ಏನು ನಾವು ಬೇಸಿಕ್ಸ್ ಎಲ್ಲ ಕಲ್ತವಲ್ಲ, ಪ್ರಾಪರ್ಟೀಸ್ ಎಲ್ಲ ಯೂಸ್ ಮಾಡಿದ್ವಿ, ಕನ್ಸೆಪ್ಟ್ಸನ್ನು ಅರ್ಥ ಮಾಡ್ಕೊಂಡ್ವಿ. Using all those things, let's solve some questions on whatever we have studied so far. Okay, the question says, find the principal value for the following. Well, this is very easy questions. This will come for 1 mark question. So to know this thing, you should be knowing this table from 10th standard. I hope all of you know this table. Okay, yeah, we'll start solving the questions now. Sine inverse 1 by root 2. Sine ಯಾವ ಆ್ಯಂಗಲ್ ನಿಮಗೆ 1 by root 2 ಕೊಡುತ್ತೆ? There you can see that is 45 degree, means pi by 4. You can pause the video and you can write for all. Now cos inverse root 3 by 2. Root 3 by 2 ಆನ್ಸರ್ ಯಾವಾಗ ಬರುತ್ತೆ ಹೇಳಿ? 30 ಡಿಗ್ರಿ ಇದ್ದಾಗ ಬರುತ್ತಲ್ವಾ? ಸೊ ದಿಸ್ ಈಸ್ pi by 6. ಕೊಸೆಕ್ ಇನ್ವರ್ಸ್ 2 ಇದೆಯಪ್ಪ, ಇದನ್ನೇನು ಮಾಡ್ತೀನಿ ಗೊತ್ತಾ ನಾನು? ಫಾರ್ ಟೈಮಿಂಗ್ ಇದನ್ನು ಸೈನ್ ಇನ್ವರ್ಸ್ 1 by 2 ಅಂತ ಬರೀತೀನಿ. ಯಾಕೆ ಹೇಳಿ? ಫಸ್ಟ್ ಪ್ರಾಪರ್ಟಿ ನೋಡಿದ್ವಲ್ಲ, ಕೊಸೆಕ್ ಇನ್ವರ್ಸ್ದು ಸೈನ್ ಇನ್ವರ್ಸ್ ಬೇಕಂದರೆ ಜಸ್ಟ್ ಇದನ್ನು ರೆಸಿಪ್ರೋಕಲ್ ಮಾಡಬೇಕು ಅಷ್ಟೇ. ಸೊ ಅದಕ್ಕೆ 1 by 2 ಇತ್ತಲ್ವಾ, ನಂಗೆ ಸೈನ್ ಇನ್ವರ್ಸ್ ಬೇಕಂತ ಇದನ್ನ ರೆಸಿಪ್ರೋಕಲ್ ಮಾಡಿದ್ದೀನಿ. ರೆಸಿಪ್ರೋಕಲ್ ಏನು ಮಾಡಿದ್ದೀನಿ ಹೇಳಿ? ಸೈನ್ ಇನ್ವರ್ಸ್ 1 by 2 ನಂಗೆ ಗೊತ್ತಿದೆ. 1 by 2 ಅಂದರೆ 30 ಡಿಗ್ರಿ, ವಿಚ್ ಈಸ್ pi by 6. ಸಿಮಿಲರ್ಲಿ ನೋಡಿ, ಸೆಕ್ ಇನ್ವರ್ಸ್ ಇದೆಯಲ್ಲ, ನನಗೆ ಕಾಸ್ ಇನ್ವರ್ಸ್ ಬೇಕಂದ್ರೂ ಏನು ಮಾಡಿದ್ದೀನಿ ಹೇಳಿ? ಇದನ್ನು ರೆಸಿಪ್ರೋಕಲ್ ಮಾಡಬೇಕು. ಸೊ ರೆಸಿಪ್ರೋಕಲ್ ಮಾಡಿದರೆ ರೂಟ್ 3 by 2. ಸೊ ವಾಟ್ ಈಸ್ ಕಾಸ್ ಇನ್ವರ್ಸ್ ಆಫ್ ರೂಟ್ 3 by 2? ಎಷ್ಟು ಬರುತ್ತೆ ಹೇಳಿ? ಅದು ಕೂಡ ಮತ್ತೆ 30 ಡಿಗ್ರಿನೇ ಬರುತ್ತೆ, ಅಂದರೆ pi by 6. ಸೊ ಹಾಗೆ ಇದನ್ನು ನೋಡಿ ಏನಾಗುತ್ತೆ? ಕಾಟ್ ಇನ್ವರ್ಸ್ ಆಫ್ ರೂಟ್ 3 ಅಂದರೆ ಇದನ್ನು ಹೀಗೆ ಬರಿಬೋದಾ? ಟ್ಯಾನ್ ಇನ್ವರ್ಸ್ ಆಫ್ 1 by ರೂಟ್ 3 ಬರಿಬೋದಾ? ವೆರಿ ಗುಡ್. ಸೊ ಟ್ಯಾನ್ ಇನ್ವರ್ಸ್ 1 by ರೂಟ್ 3 ಯಾವಾಗ ಬರುತ್ತೆ ಹೇಳಿ? ಮತ್ತೆ 30 ಡಿಗ್ರಿ, ಅಂದರೆ pi by 6. ಟ್ಯಾನ್ ಇನ್ವರ್ಸ್ 1 ಯಾವಾಗ ಬರುತ್ತೆ ಹೇಳಿ? 1 ಯಾವಾಗ ಬರುತ್ತೆ ಅಂದರೆ 45 ಡಿಗ್ರಿ ಇದ್ದಾಗ ಅಲ್ವಾ? ಸೊ ದಿಸ್ ಈಸ್ pi by 4. So these are simple 1 mark question, can be asked in the exam. Please pause the video and note it down. Now let's take the next questions, wherein I have negative signs. For this one I am going to use the second and third property. Whenever I have negative sign inside sine inverse, that negative comes outside. So this will be minus of sine inverse half. So now minus as it is, sine inverse of half ಅಂದರೆ ಮತ್ತೆ 30 ಡಿಗ್ರಿ, ಆನ್ಸರ್ ಈಸ್ pi minus pi by 6. ಹಾಗೆ ಟ್ಯಾನ್ ಇನ್ವರ್ಸ್ ಒಳಗಡೆ ಮೈನಸ್ ಅಂದರೆ ಕೇವಲ ಮೈನಸ್ ಹೊರಗಡೆ ಬರುತ್ತೆ, ದಿಸ್ ಈಸ್ ಟ್ಯಾನ್ ಇನ್ವರ್ಸ್ ಆಫ್ √3 60 ಡಿಗ್ರಿ ಅಂದರೆ -π/3 ಆಗುತ್ತೆ. ಇಲ್ಲಿ ಭಾಳ ಕೇರ್ಫುಲ್ ಆಗಿರಬೇಕು ಮೈ ಡಿಯರ್ ಫ್ರೆಂಡ್ಸ್, ಬಿಕಾಸ್ ಕಾಸ್ ಇನ್ವರ್ಸ್ ಒಳಗಡೆ ಮೈನಸ್ ಬಂದಿದೆ. ಸೊ ಕಾಸ್ ಇನ್ವರ್ಸ್ ಒಳಗಡೆ ಬಂದರೆ ಮೈನಸ್ ಬಂದರೆ ಕೇವಲ ಮೈನಸ್ ಹೊರಗಡೆ ಬರೋದಿಲ್ಲ. ವಿ ಶುಡ್ ರೈಟ್ ಆಸ್ ಪೈ ಮೈನಸ್ ಕಾಸ್ ಇನ್ವರ್ಸ್ ಆಫ್ ಹಾಫ್, isn't it? So now this is equal to pi minus cos inverse of half ಯಾವ ಬರುತ್ತೆ ಹೇಳಿ, 60 ಡಿಗ್ರಿ ಅಂದರೆ π/3. ಸೊ ಇವಾಗ ನೋಡಿ 3π minus π, ದಿಸ್ ಈಸ್ 2π/3. ಹಾಗೆ ಇದೇನಾಗುತ್ತೆ ಹೇಳಿ, ಟ್ಯಾನ್ ಇನ್ವರ್ಸ್ ಒಳಗಡೆ ಮೈನಸ್ ಅಂದರೆ ಏನು ತೊಂದರೆ ಇಲ್ಲ, ಮೈನಸ್ ಆಫ್ ಟ್ಯಾನ್ ಇನ್ವರ್ಸ್ 1 ಆಗುತ್ತೆ, ದಿಸ್ ಈಸ್ -π/4. ಕೊಸೆಕ್ ಇನ್ವರ್ಸ್ ಒಳಗಡೆ ಮೈನಸ್ ಅಂದರೆ ತೊಂದರೆ ಇಲ್ಲ, ಡೈರೆಕ್ಟಾಗಿ ಮೈನಸ್ ಕೊಸೆಕ್ ಇನ್ವರ್ಸ್ √2 ಬರೆಯೋಣ. ಸೊ ದಿಸ್ ಈಸ್ ಮೈನಸ್ ಸೈನ್ ಇನ್ವರ್ಸ್ 1/√2 ಆಗುತ್ತೆ, ಅಂದರೆ -π/4 ಆಗುತ್ತೆ. ಸೊ ಇಲ್ಲಿ ಇಂಪಾರ್ಟೆಂಟ್ ಬಂದು ಇದು ನೋಡಿ, ಎಕ್ಸಾಮಲ್ಲಿ ಇದೇ ಕ್ವಶನ್ಸ್ ಕೇಳ್ತಾರೆ. ಯಾಕಂದರೆ ಕಾಸ್ ಇನ್ವರ್ಸ್ ಒಳಗಡೆ ಮೈನಸ್ ಬಂದಾಗ ಪೈ ಮೈನಸ್ ಬರೀಬೇಕು ಅಂತ ನಿಮಗೆ ಗೊತ್ತಿರಬೇಕು. ಸೊ ದೀಸ್ ಆರ್ ದ simple questions which I have taken from NCERT. Still there are some questions available in the NCERT. You can check them and you can do it. ಏನು ತೊಂದರೆ ಇಲ್ಲ ಆಯಿತಾ. ಸೊ ಇನ್ ದ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಐ ಆಮ್ ಗೋನ್ ಟು ಡೀಲ್ ಸಮ್ ಮೋರ್ ಪ್ರಾಪರ್ಟೀಸ್ ಆಫ್ ಇನ್ವರ್ಸ್ ಟ್ರಿಗ್ನೋಮೆಟ್ರಿಕ್ ಫಂಕ್ಷನ್ಸ್. ಸೊ ಪ್ಲೀಸ್ ಸಾಲ್ವ್ ದ ಕ್ವಶನ್ಸ್ and get ready for the next class. Till then, take care. Bye.